Question 6 says, supply the missing values for each table. We're first of all told that this is arithmetic. That means as we move forward, as x increases by 1 unit, we're going to be adding a constant to our y values. One of the things I notice is that if I add 2 jumps to this, I go from a negative 12 to a negative 8. So that's an increase of 4 units, right? I've increased by 4 units in 2 jumps. So that means each time I'm moving forward, I'm increasing by 2 units. So negative 12 plus 2 would be negative 10, and negative 10 plus 2 is negative 8. Negative 8 plus 2 is negative 6, plus 2 is negative 4, and then negative 2. So this is the arithmetic sequence. Each time we're going up by 2. Also, you can see our y-intercept here is at when x is 0, y is 12. So you can write the equation of this. This is y equals 2 times x minus 12. Right? Again, we're adding 2 each time. That's why there's a 2 times x there. And we're starting at negative 12. And if you plug any of these values in, if I take the number 4 and I put it into this function, this becomes 2 times 4, which is, and then minus 12. 2 times 4 is 8, and 8 minus 12 is indeed negative 4, which is exactly what the functional value should be at that point. So this is the rule for that function. If I look at this table, it says this is a geometric sequence, so I know as I move forward, as x increases by 1, I'm multiplying by the same value each time. And one of the key things I could do is look at the fact that there's a 72 and a 12 that are right next to each other. And in order to quickly answer the question, what am I multiplying 12 by in order to get 72? I could just look at 72 divided by 12. And it turns out that that is the number 6. So as I move forward here, 12 times 6 is 72. So that's kind of a key insight, so that I know that I'm multiplying by 6 each time. And that'll in fact allow me to fill in the sequence starting from the beginning. So 1/3 times 6 would be the number 2. 2 times 6 is 12. Got it? 12 times 6 is 72. 72 times 6 should be 432. And then 432 times 6 should be 2,522. So this is the values that are in this table. This next question will do it since it's here and it's related. Question 7 says, write the equation, write an equation in the form y equals a times b to the x for the geometric sequence that's in question 6, part B. So we're looking for an equation for this. And if I look at it, remember, I'll copy this down, y equals a b to the x. This is my 0th term, or my starting value, and you can see I'm starting at 1/3. And this b value here is my multiplier. It's the value I continue to multiply by, and I keep multiplying by 6. So the function should be y equals 1/3 times 6 raised to the x power. And it doesn't matter which value of x I pick. When I put it in there and evaluate this function, I'm going to get exactly the y value that's indicated. So 6 to the 3rd power divided by 3, or times 1/3, is indeed going to be 72. And you can plug that into your calculator and verify that if you put a 3 here and then divide by 3 or multiply by 1/3, you're going to get 72 out of it. So this is the answer for move it over here. This is the answer for part or question 7.